on the 8 attendees. Sure, hopefully everyone gets joined later. Oh, cool. What are they seeing? Are they seeing the?
Wait, I'm refreshing. There we go. Yeah, they're showing up. Yeah.
Cool. Awesome. Okay. Cool. Great.
Yeah, and they're hearing us right now.
Yeah. Oh.
So again, hi, hello everyone. We're gonna start in around 8 minutes or so. In the meantime, you could ask questions if you're on YouTube. Ask questions over at the chat. If you're on Zoom, there is a Q&A button over at the bottom of your Zoom screen, so you could ask questions through there as well. And we already have our first question on. We haven't started yet, and we have our first question. We'll get to that later. Once we've started.
Yeah, I can.
Okie dokie. Thank you.
Ben, when you say 0.8 CPU core, are you talking about 0.8 gigahertz or?
No. Yung sa Kubernetes, diba you set it by millicores, yeah.
Right.
So Ben, why Go language?
Super lightweight for us. I don't think you can get this performance with other languages. I mean, like, not of course like compared to C or like Erlang, but yeah, like we can run the whole program with even like 200 MB. We tried it, and similar performance.
Oh, Ben, you're a dad. I didn't know that. Sorry about.
Yeah.
So bad.
Mm-hmm.
I'm just reading what I'm supposed to say later. That's great.
Yeah, to kids. Kinulong ko muna sila dun sa other room.
Actually, yun yung problema mo ngayon. They're just up there. So let's see. Hopefully they don't decide to scream in the middle of me introducing you. It should be good.
Mm-hmm.
I was actually asking May if she could take over because like the eldest one wasn't in such a good mood when he woke up kanina like this afternoon, so I was not sure if I'll be able to host properly. But he looks like he's okay now. We'll see. Alright. 4 minutes. Hello guys. Hello everyone who are in the Zoom call and also on YouTube. I also haven't checked YouTube. Sarah, how do you see the people? How many people are in the YouTube
In
video?
YouTube,
Like,
under
yeah.
live chat, if you click on those three button menu thingy there,
Oh, I see.
clicking on the participants
Participants.
will
I
usually
see.
show something.
Oh, it just shows us.
Or
Oh, that's
mostly if someone says something, yeah.
I see.
I don't see anything here that shows if how many people are currently viewing.
Yeah, you're right. That's okay. That's fine. Right. 3 minutes.
Again, to everyone who is on the Zoom webinar, hi, hello. If you can just click on the Zoom group chat and uh, chat with all the other attendees there while we are waiting for things to start.
11 people. Cool. Almost like our in-person meet.
Yeah,
Yeah.
awesome.
Cool. 1 minute to go. Exciting. Hello, Buhay OFW to Singapore. Hi.
Philippines din.
Do you know him? Do you probably know this guy, Ben? Yeah.
Mm.
There's a guy named Buhay OFW Singapore on our YouTube. Great. That's great. Hello, Kriya. Okay. Check. See. Copy that.
Yeah, I'll share my screen. You guys can see it?
Yes, sir. You see it.
All right. Yeah. So hi. Today I'll be talking
Oh,
about location aware.
and then wait.
Sorry.
We're not yet. Like we have 3 minutes. I'll intro you and then we can start.
Ah, yeah. Sorry.
It's all right. All right. We're going, Johnny. We're live. We're hot. Okay, cool. All right. Good evening, guys. Um, Welcome to our first Go Manila remote meet. I guess for the lack of a better term. I know we haven't had like a proper meet ever since I think it started with Tal, and then obviously COVID-19 hitting us also. But it's nice to be back. I'm with Johnny, Charo, May, Barch, and the rest of the organizers. Um, Thank you to Freelancer also for lending us Johnny and his expertise in putting all these online things together. Really, really cool. Okay. So without further ado, I'll just introduce our speaker for tonight. So Ben Sarmiento has been in the tech industry for 9 years, and he started when he launched his own SaaS company in college. Oh wow, in his college dorm room one summer. And then after four companies and three acquisitions, he's now working as an engineering manager for FoodPanda and Delivery Hero, and based in Singapore with his family. Outside work, he spends his time playing with his children Juju and Lilu. Right. So he'll be talking about creating a location aware marketing carousel. And he'll try to demonstrate how Go DynamoDB and geohashing will allow us to do location checks millions of times per second with just zero point 0.8 CPU core and 600 megabytes of memory. So again, let's give it up for Ben. If you guys have any questions, just let's reserve that later towards the end of his talk. You can ask on our YouTube live chat, or if you're on the Zoom call, on the Zoom webinar, you should be able to ask there too. All right. All right. You can take it away, Ben. Thanks.
Yeah. Thanks, Michael. So today I'll be talking about location-aware marketing carousel, and this is one of our projects in FoodPanda, and this will be the outline for my talk. I'll do some intro first. I'll introduce you to the problem as well, and I'm gonna give you the solution that we did, me and my team, and some Q&A at the end. So about me, I'm working under Delivery Hero. So Delivery Hero is actually the parent company of FoodPanda, and I'm working there as an engineer manager, and I'm also a full stack developer. So I'm also a self-learned programmer. I didn't have any like formal education about programming. And prior to Delivery Hero, I was working with Carmudi, which was acquired. I worked there as a CTO, and then Cloud Sherpas, which was acquired by Accenture, and as well as Bright, which was acquired by LinkedIn. So FoodPanda is a food delivery website or app. We started May 2012 in Singapore, and then in December, 4 years after, we were acquired by Delivery Hero, and now we are present in 11 countries, including Philippines. So the Philippine arm of the business was actually launched 6 years ago, and prior to the pink color scheme that you see now, we were doing this orange color scheme. So now the problem. So if you open the FoodPanda app, you will see the campaign carousel or the marketing carousel. So this has a premium placement on the apps. You can see it almost at the top, and you will see different tiles here, which are campaigns. So the architecture here is very simple. A user opens the app, the FoodPanda clients, which can be the web client, Android or iOS, and the clients request the list of campaigns. The request goes through our campaigns API, and our campaigns API sends back the list of campaigns. And our API is built using Go and DynamoDB, and it's all hosted using Kubernetes as our platform. So to give you more context about the problem, I need to talk about what a campaign is. So a campaign it's something that our marketing people creates. So this is our back office tool that we also did, also one of our projects, and this is where all the campaign configuration happens. So there's this part here that's called vendor selection, and vendors are basically the restaurants that you see here. So vendors are right, is a food delivery business. So this is what a delivery area of a vendor. And you can see different colors here, so green, blue, and red. And I'm not sure if everyone is familiar with, but they have different meanings. And the green ones, sometimes they are this is the area that is covered by free delivery. Sometimes, well, basically the lowest tier of delivery fees. The blue one, of course, the mid level, and then the red delivery area here is the highest delivery fee. So this is not what it actually looks like in production. We have here a more realistic data, and you can see that the delivery area looks a lot more complex, and it's configured a lot more different ways. So how do we show campaigns based on the user location? So this talks about a lot more about relevance, and relevance means that we have to make sure that there is at least one restaurant delivering to the user before we show the campaign tile. So as you can see from this image, the user located near many restaurants see a different type of carousel than a user who doesn't. So yeah, this is more of a user experience problem. So how do we solve that problem is by checking one by one if the user location is inside the delivery area. So here is one scenario where we have this campaign. This campaign has 3 restaurants, and each restaurant will have 3 different delivery areas as well. And basically, we get the user's location from the clients, and then we check one by one whether the user location is inside the delivery area. And that is more of a mathematical problem and could be solved by existing Go libraries. So on this example, we found that on restaurant 3, the third delivery area of that restaurant, it's covering the user location. So we showed this campaign 1 to the user. So now, considering all the factors, we are doing, we have approximately 10 active campaigns per country. We have 10,000 restaurants per campaign, and then we have 10 delivery areas per restaurant. That amounts to around 1 million location checks per location. Um, yeah, so so this is like more of a worst case for us, and we got this from the different data that we got from different countries. So currently we are serving customers to 18 different countries. So this 1 million location checks multiplied by the number of countries as well. And also take note that this 1 million location checks, they're all being done in just a single request. So what we need to do then to solve this problem is, well, one thing that Go is known for is about concurrency. So what we can do is to parallelize all the location checks that we do. And we can do that using the different concurrency patterns out there, like wait groups and channels and go routines. So this is like the version 0 of our code when we first created the initial draft of the solution. So basically, we have this check if vendors deliver, where we well, this from coming from a list of campaigns. So we do a for loop inside. We iterate on every campaign. We get the vendors. We get the customer location. We also pass in the ID for reference later on. We pass a channel. Basically, this channel accepts all the visible campaigns and also the wait group. So wait group is something that you use to basically wait for a group of grow routines running together. So once all those grow routines are done, this will this will also invoke, and I mean the execution of this WG that wait will end. So inside check if vendors deliver, there's another for loop for the iteration of all the vendors linked to the campaign. And then inside that is another go routine called check if inside delivery areas. And again, another for loop inside the check if inside delivery areas is, since we have multiple delivery area, we can only check for one delivery area at a time. So we do another check, but this one, there's no for loop inside. So yeah, so we're using this library called Geos or GoGeos. And yeah, so we convert the coordinates of the delivery area into a polygon, and then we use the Geos library to check whether the customer location is inside the polygon. And then if it does, we just return a campaign ID. And then the campaign ID is passed to the visible channel. And then at the end of this wait group execution, the channel is closed and we get all the campaigns of that should be visible for that user. So yeah, I mean, by having this solution, this approach, we easily hit the max number of Go routines, and the maximum number of Go routines is different from machine to machine. So on our case, excuse me, we are running on these limits. We have 800 millicore CPU set in Kubernetes. We also have 600 MB of memory, and we set our HPA, our horizontal pod auto scaling maximum to 10 pods. So basically, this approach that I just showed you won't work. So I guess we can do some optimizations, and by optimization I mean we can skip some vendors here. For example, if we know that the vendor city is not really delivering to the customer location, we can skip those vendors, and also merging the delivery areas. And merging the delivery areas is the reason why we use this GoGeos library. It's because the API for merging different polygons is super simple. So if we merge the delivery areas, we can actually iterate to a lesser number of delivery areas, making the iteration faster. And other optimizations, like I remember there was one iteration where there was one version of this code wherein we close the we close the channel earlier. We have the wait group execute faster. So I mean, if we found a match already, we will cancel the execution for that campaign, because that means that the campaign will already be shown to the user anyway. So yeah, but those things won't work because we will also hit other problems like memory consumption and also response time. Something about consumer facing apps is that you have to achieve as fast of a response time as possible. So in our case, we were trying to aim initially for 100 milliseconds or less. Something about marketing carousels, by the way, they're always lazy loaded. So that means that the user should always see the carousel as soon as possible. They're not on the critical path. They're not on the order path. It's not a pre-requirement for the user to order food in our website. So it's always lazy loaded. So now we jump to the solution. Oh, actually, one more thing. Something about memory consumption is um, I think this is similar to Java, is that Go doesn't respect mm, the memory limits that you set in Kubernetes pods. So even if you set 600 megabytes memory, if your pod hits 600 MB, it won't actually run the garbage collector. The reason being, the pods or the Go garbage collector itself sees the host memory. So yeah, this is also an issue similar to JVM. But in Go, there's no, even if you hack the I mean, in some way you can configure the JVM in Java to see the host memory see the pod memory instead of the host memory. In Go, there's no way. So you always want to make sure that there are no memory leaks in your application. Anyway, now jumping to the solution. Um, I think that the approach right here, it's very clear that we won't be able to reach our um, because at this time when we were having these problems, we were at that time only receiving around 10,000 requests per minute, and we want to increase that because I mean we need to basically find a way to make the solution a lot more scalable. So we had to take a step back and rethink our solution, and that's when we came up with geohashing. So basically, geohashing is you divide the whole world map into different tiles, and then you assign letters and numbers to them. And then as you go deeper into the map, you also increase the precision or the length of the geohash. So for example, this tile right here, this is the G geohash tile. And then inside Greenland, you can see some areas GJ, GM, so those are geohashes. And as you increase the geohash length, you are also decreasing the size of the tile. So um, geohash G right here, the width and the height of this tile is around 5,000 kilometers. I think the first iteration of our solution was to use geohash length 4, which is around 40 kilometers. So I think at some point in time we went with lower geohash lengths. And how do we apply this to our use case before? So example, let's go back to the first example earlier, where we have multiple campaigns, and then inside the campaign you have restaurants and delivery areas. So first we have to generate the geohashes, and the geohash generation is pretty simple. You have a set of coordinates right here, and then you just get all the geohashes covering this area. And so yeah, the bounding box right here is the coordinates here are the bounding the vertices of this bounding box. And you can also see that the geohashes that covers this is well, this area at least is are these 4 geohash tiles. So there is a compromise in accuracy here, and this is illustrated right here. So if we go back to the example earlier, the delivery area of one vendor looks like this, and then this is the geohash tile. So we consider this geohash tile covering this delivery area. That means that if we convert this delivery area into geohash, this will be part of that delivery area now. And so even if the user is a bit outside of the delivery area, that means that we will still show the campaign because the geohash is still covering it. So yeah, this is a compromise in accuracy, and that is fine because we are getting a lot in return with performance. So this is just a matter of communicating well to your users what the expectations are. And I think this is fine because we are more of doing marketing functions instead of aiming for the accuracy part. So now we have to do is map the campaign ID with geohashes. So we have the different campaign IDs here and the geohashes produced from this. So we just map them basically. So campaign ID and then the restaurant geohash. So now what will happen to the location check? So the first two steps are still the same. The customer opens the app, the client sends a request, and then sends a list of campaigns from campaign API. Also along that request, you will also include the customer's geo coordinates. Inside the campaign API, now this is the crazy part. Um, you have to convert the customer's location, the geo coordinates, to a geohash with the same precision as the geohashes that you generated prior to this step. So when you create the campaign, you do this mapping of the delivery area geohash and the campaign ID. Now that precision that you've used in this step will now be the precision that you also use when you convert the customer's location to the geohash. And now you get the list of campaigns, and then for each of the campaign, you query the database to check if the campaign ID, customer geohash, this mapping exists. If yes, then we can show the campaign to the user. Now we send back the list of visible campaigns to the front end. So again, the query will look like this. The campaign ID, the mapping of the campaign ID and the customer geohash should equal to the campaign ID and the restaurant geohash. And they should always have the same position. And then, yeah, once the response is returned, the customer will see the carousel. And now, instead of doing the very complex parallelization that you've seen in this part of the code, yeah, right here, all these location check will now be just a single query on the database by just doing geohash. So yeah, to illustrate the process more, here we convert the user's coordinate to a geohash. So latitude 1.3, longitude is 103, and then the geohash generated is actually it's a bit longer than this, but we truncate the data because we need to match the precision of the delivery area geohash. So here we use the W21ZS. Now we get all the campaigns in Singapore, and then we do the mapping of the customer geohash and the campaign ID. So these are all the campaign IDs and the customer geohash. And this on the right side is the index of our database. So this is the list of delivery geohashes. So the campaign and then the delivery geohash. Again, this is the campaign and the customer geohash. And then you compare them with the campaign and the delivery geohash. And since you see campaign 1 W21ZS here on the index, then we know that campaign 1 will be shown to the user. So campaign 2, since there's no W21ZS right here, we don't show it to the user. Same with 3 and 4. So how do we optimize this with Go? Is first we cache the list. Of course, this list of active campaigns of a country is always the same for all the users requesting for the carousel. And for our use case, we don't use something like Redis. I mean, we could use that, but we want to achieve lower latency. That's why we went with an in-memory cache. And for our use case, we're using Ristretto, which is a high performance caching in-memory cache in Go. So we cache this list using Ristretto. We parallelize, same as the approach that we did earlier using Go routines and wait groups. And basically what we do in DynamoDB is a key begins with query. And this is what it looks like in our DynamoDB database. So we have the sort key in this format, the campaign ID and the geohash. So if you use the geohash as part of the sort key, then of course you can expect that the performance will be a lot higher. And one thing about DynamoDB and Go is unmarshalling takes up a lot of memory. So in this case, you do not unmarshal the results. Unmarshalling meaning like converting the DynamoDB JSON into Go instances, Go struct instances. But instead, you just get the result that count. So instead of unmarshalling the results and then counting them, you just get the result that count. So yeah, into the final pointers. So so there's one pitfall that we discovered while working with DynamoDB in Go, and that is when you are fetching a list of maps, or yeah, basically a struct array. Unmarshalling consumes significant amount of memory, and that is because the tree being made is more complex than you think it is. So, for example, on this, you can see that the data is a map, and then there's a type that is added to the JSON that adds another level on that tree, and then the fields of that map, and then the type as well, and then the value. So it's a lot worse when you have a list of maps. So, for example, our DynamoDB JSON representation for delivery areas. So delivery area is a list of maps, which is which looks like this, and then maps will have the fields. The fields will have the type as well, which is a list. The list will contain another list. The list will contain another list, and then that's the time it will contain the coordinates itself. So unmarshalling takes up a lot of memory because at the same time, there's a lot of levels here, and at the same time, there will be other types in Go that will point to a nil value. Because if you unmarshal this list, it will contain the list value, but it will also contain map and the string and the numeric value all pointed to nils. So there is some significant memory consumption there if you are working with a very big list, for example, for delivery areas. So one thing that you should do is to exclude the field by projection if you don't need the value itself, which I think is a best practice, whether it's NoSQL or MySQL or anything. And then if you really need the value, then consider optimizing the encoding by using a comma separated string type instead of using a list type. Yeah. And another thing that we use is called a pattern that we use in DynamoDB is called single table design, and this paradigm is being advocated as well by Amazon, by Amazon themselves. And what this brings us is that provisioning is simpler. Of course, there's only one table that you're using on your application, so you don't need to always provision a table every time you introduce a new model. But the thing is, you have to really plan all your access patterns before you create the table. Because, for example, when you create a table in DynamoDB, you won't, and then you only created like one or two local secondary index, you cannot add additional LSI anymore on your table because you need to delete your whole table again before you can add those. So yeah, make sure that you consider those restrictions as well when you are using single table design. And like this will only, I think this is only feasible if you have a general idea of what the access patterns are of your application. Like for example, for us, it's a campaign service. We know that it will need to get active campaigns, maybe inactive campaigns, also like a single campaign. So these things you need to pre-plan for them when using single table. And yeah, one good thing about single table is that you are always thinking of how to optimize your queries by using indexes. So like sort keys and primary keys, we planned for those, and also using LSIs, and of course GSIs. But yeah, that's another topic for discussion. Just make sure to check this video out if you are interested on using single table design for DynamoDB. And yeah, with load testing, which is very important for all consumer facing APIs, we were able to reach 470,000 peak requests per minute, and also achieving this with 1.5 millisecond average response time. And again, all these things are essential in order to reach this level of performance as well. And yeah, we don't think that it will be possible by using other languages, because we are working with almost like low end, not really low end, but like um, low tier resource for a pod. Like it's not even a full core. So sometimes we hit like blocking. We hit problems like our Go routines getting blocked or something. But yeah, we are able to resolve those by making sure that all our codes are optimized using Go. And that's it. Thank you. Yeah, time for the Q&A, I guess.
Thanks,
Yeah, by
Ben.
the way, I put in a link here. Yeah.
Oh, okay.
Yeah, I put in a link here. This page right here displays you all the updated voucher codes in FoodPanda.
Oh, cool. That's great. Thanks. Thank you for that freebie. Yeah, guys, if you have any questions, please, yeah, just feel free to ask. If you're on the Zoom call, just ask on the Q&A panel, and then if you're on the YouTube channel, we'll just monitor the chat. So just if you have any questions, just ask away. Charo, I guess you can help me with this. Hello. Okay.
Okay,
Well, I
yeah,
guess
hi. We're back. We have two questions right now on Zoom. One is it says here SRI. I don't know if this was answered already.
Yeah.
SRID or S2 library for GIS?
Yeah, I think for we were discussing this before when we were planning the architecture of our app, and we saw we saw S2. We were choosing over S2 or GoGeos, and I think we went with GoGeos because of the simpler API. We had this use case uh, for merging polygons in our application, where we saw that GoGeos has a is GoGeos way of doing it was very straightforward compared to S2. So even though S2 is more of the de facto solution when doing geo work in Go, we still went with GoGeos because it's simpler. Yeah, I hope that answers the question. Sorry guys, can you still hear me?
Yep. Are there any other questions? Sorry, I'm monitoring on the.
Okay. So sorry. Thank you. Yeah, thank you for that question, Kirk. So there's another question from Raul. He says, "Great talk. Given that you use in-memory cache and cache invalidation is a hard problem, how do you perform coordinated cache invalidation of campaigns? For example, when one of the active campaigns is updated or deactivated or campaign to geohash mapping is changed."
Right. Yeah, I think this um are really uh I mean it's a problem that we recognize in our application. Even recently, we had this problem wherein we think that the list of campaign consistency is not that important, so we kind of increase the latency of this. I mean the expiry time of the cache, and like from 1 minute we went with 5 minutes. So I think we're still benchmarking this. Before we had a version of cache invalidation where it was a bit complex. It was tracking individual expiry times for each item, but at the same time, we want. I mean, there was really not much use case for us for tracking individual campaigns. So we went with something a lot more simpler. We just choose a duration for valid cache values, and then we went ahead, and right now we're still benchmarking. And yeah, I mean, the good thing about memory cache is it's very fast compared to Redis, where there's network overhead. The bad thing though is that every time you spin up a new pod in Kubernetes, you always start fresh. So all the initial requests for that pod will, of course, consume memory, consume CPU because there's nothing on cache to return. And you have to consider this when configuring your DynamoDB, your Kubernetes pod limits, because that initial surge of requests might also kill your pod, right? Like there's only 600 MB and you need to account for that initial surge of 600 are you able to fit in all the initial requests inside 600 MB of memory? So those things you need to measure on your load test, especially if this is something that goes into production. Yeah, sorry. Yeah, I was able to open the Q&A window, by the way.
All right.
I guess I'll just go over them. Um,
Yeah, sure.
how did you find out the memory utilization with regards to serialization? Say if one doesn't know which parts of a service eats a lot of memory, how do they go about finding the memory hog? How did you do it? Oh yeah, there's we use this memory profiling tool. Actually, let me try to recall the tool. Hmm, anyway, we did use this memory profiling tool where we just added some very few lines in our code, and we run our code in production, and this will generate a log for us during those initial phases of our diagnose for the memory leaks. And what we found out is, well, the reports basically told us what function in your code eats the most amount of memory. And by then, we could already tell that it's the marshalling and unmarshalling of data that's taking a lot of memory. And yeah, we did dig deeper into this, and we found out it's actually inside the DynamoDB SDK itself. It's because there was a very big list of maps that it's also eating a lot of memory. So yeah, we just went with the solution was basically to remove that on the projection expression in DynamoDB, so it will not go with the unmarshalling of this big list. Yeah, I forgot the name of the tool. Sorry. I'll send it to the chat once I find it. Yeah, do you correct or filter the inaccuracies of geohashing? For example, getting a restaurant that cannot reach the customer. Yeah, for sure. One thing that we do, one thing that we can do is to increase the geohash length, meaning to increase the precision of the geohash. Basically, when you increase the precision length, you also decrease the size of the geohash tile. So if we go back to am I still sharing my screen?
No.
No. Anyway, if we go back to the part wherein we convert the geohash, the delivery area to a number of geohashes, that means that we will just generate more geohashes for that delivery area, because we also want to achieve the fidelity of the original delivery area. So yeah, by increasing the geohash length, we can of course account for the inaccuracies, but it will never be 100% accurate. That's the thing with geohash. Yeah.
Okay. So we have three other questions coming from the chat on YouTube. We have one
Mhm.
from Mary Rans. How long did you use your version 0?
So like yeah, another thing about Go is that it's super easy to learn and use. So prior to joining FoodPanda, everyone on our team doesn't have any Go knowledge or experience. But yeah, we did have experience with other languages. So we know about memory profiling, about CPU profiling, about all those things. So when we dived into Go, and then we encountered these issues, we already know what to do by doing a memory profile of our application. Um, we saw what functions were consuming a lot of memory, and we discussed solutions. And from that discussion, we found out that we can solve it by our initial version of code. And and then but and then we decided to probably let's look at other solutions. Probably we can do this with Geohash or something. So yeah, um, I think at that time it was just a matter of days. So like version 0 was up probably for 3 days, for 2 or 3 days before we identified that there's some limiting factor on the RPM of the API. And after 3 days, we huddled the team together and discuss how do we deal with the issue. And then I think basically that was just a span of 1 week that version 0 was running in our production. Mm, yeah, hope that answers
Okay.
the question.
All right. Thank you. So there's another question from Jorik Caberio. What version of Go are you using in production, and do you use modules?
Yeah, we are using modules. So um, um, yeah, we're always using the latest version of Go. I'm the one who always updates it to the latest version every time our new release comes in. I think we started using Go 1.13. I think now it's just Go 1.14, right? I only updated once. So the good thing about Go is that yeah, it's very straightforward to update from the next version. As long as there's no breaking change. Well, for us, it's we're lucky because there's always no yeah, there's no breaking changes. What's the other question? Again, sorry, there were two questions, right?
Yeah,
Go
he
modules,
was
sorry.
also
Yeah.
asking if you use modules.
Yeah, I think that's a requirement when you're developing now with Go. Um, we are, I think something special about our setup is that we have this campaigns API, right, which is a public API, and we also have um, what do you call this? The API that serves the back office. I've shown earlier the back office tool that we have for configuring campaigns, and these are two Go modules that are inside a single repository. So we're doing this monorepo setup with two Go modules, and the thing is we cannot share modules between. I mean, we cannot share uh, code between the two. Like say if we define a repository on the private API and then reuse that on public API, having two modules in a single repo for some reason prevents us from reusing that code. So right now we have this issue about duplication in our monorepo setup, and yeah, that's becoming a problem. But in the future we want to try having a third module to host all the shared components of two of our APIs.
All right. And then there's another one from Don Vito. Did you achieve that performance using the same limits in Kubernetes, like 10 pods, which you've shown earlier?
Yes, just 10 pods of those pods with zero point 0.8 millicores and 600 MB RAM.
Okay. There are
Mm.
two other questions from the Zoom Q&A. Herman asks, what profiling package are you using for memory, CPU, etc.?
Yeah, I remember we used two different packages for doing memory profiling. I forgot both actually, but I think the first one was the most popular one. I think it's like a built-in tool, if I'm not mistaken.
Okay, and
Mm,
then another question
yeah.
from Kirk. How is the productivity in Go compared to other languages like JavaScript, like Node or and Elixir?
I don't have any experience with Elixir apart from a few tutorials, but I guess when I compare this with Node or JavaScript or say other languages that I've worked with like Python and PHP, I guess Python is probably the most productive language for me because the language is, I mean, everything's just easy on Python, right? Like if I think the only thing that's not easy in Python is vendoring, and it's not that straightforward, I guess, compared to other languages. With Go though, I mean the productivity is not that different to Python. Also because the approach is different in Go because it's a compiled language, it's a statically compiled language, and you have types. And yeah, um, it's easier to do, I guess, mm, bug resolution in Go compared to Python because of types. The thing with Python though is it's easier to write tests in Python compared to Go. I think this. Sorry, I did not compare to Node because in Node it's always a lot harder. I mean, for me, JavaScript is I think a language that I can't really memorize. I mean, all the complex APIs of Node and JavaScript. For some reason, I always need to look up some of the APIs of this language. So, like for example, with writing tests in React, um, I always forget how to do provider testing in React. So yeah, for some reason, I always write tests faster in Go compared to React. Yeah.
Okay. Are there any
Yeah.
other
Sorry,
questions? Yes.
just to add, yeah. As I said earlier, like prior to us working on this project, this was our first project in FoodPanda, by the way. And prior to us working on this, we have zero knowledge in Go. So like we have like four people in our team working on the back end, and I was only focused on the back end during the start. And it was not really just guessing, but more of like talking to different Go programmers as well in the company and outside the company. And it was very easy to pick up, which is a good thing, I guess, for Go.
What was the amount of time to ramp up from from someone who who has not
Mm,
used Go that much to all the way to the point that you've decided to already push the code to production?
mm, um, I think that's different from team to team, but in our case, it took us like 2 month, 1 month and a half probably to deploy something like this.
Hmm.
And to
That's still
achieve
good
this
time.
performance took us another half or 1 month. Yeah.
That's still good time. Yeah,
Mm.
that is still good time. Two other questions from YouTube. From Jorik? What web framework are you using?
The framework. I think we're using the default, the built-in one. Was it Go Web something? Oh, Go Net. Sorry. Yeah, the Net package. That was it.
Okay. And then we have again another one from Mary, another one. Have you thought of changing programming languages to solve your problem?
Um, yeah, we could, but of course we need to. I think something that we need to consider when doing this architectural decisions is about resources inside the company as well. So in our company, there is a very um, like there is a clear step towards moving everything, all the legacy stuff from PHP to Go. So when FoodPanda started, everything was just PHP, um, and and then this was just a big monolith. And when the different teams started divvying up the code, the monolith into different microservices, all these microservices were mostly written in Go. I mean, some of them are still written in other languages. For example, for payments, I think they're still using Java there. But yeah, for most of our web services, we're using Go now, and um, it just didn't feel right to choose another language than, I mean, opposing the other, not really opposing, but like different on a different language than the other teams, because you will also lose these resources, right? And another thing is, but yeah, I mean, I think resources is the the biggest thing here, because um, I mean, you will always, I mean, all the things that you need to do in your project will always be just probably just one seat away from you, right? Like you just get the pattern. I mean, how they, like for example, for feature flags, you just get the feature flag pattern that the other team is using. For like what other, like circuit breaker pattern, you just get the library that they're using from another team. You just copy that code, and yeah, I mean, it's I think that's one thing that you should always consider, how big of a resource, or how big of a resources you're gonna get from choosing a language, and also how productive you're gonna be.
Okay. Mary also has a follow-up question. What language were you using prior to coding with Golang?
In Cambodia, we were using PHP. Yeah, we are using PHP, and yeah, in the front end, also I think that was Vue or Angular. Yeah, I think both Angular and Vue. So yeah, it was just PHP, and like prior to 2 companies back, we were using Python.
Okay. And then Arnell is asking, is there any limitations you encounter when using Go?
Yeah, the one limitation that we encountered with the memory consumption, because the Go's garbage collector, um, it doesn't it doesn't really see the memory limit that it sees. So like the garbage collector, right? Like it will the trigger for the garbage collector running is how much memory it already consumes. But if it sees the host memory instead of the pod's memory, then there's gonna be some issues there if you are aiming for that trigger. So I think that's just one. It's not really a limitation, but more of I don't know. I don't know. To be honest, I don't know how to classify that, but yeah.
Okay. All right. So let's see if there are any um, other questions. So no other questions from Zoom. Last call.
We have a few questions on YouTube. I think on Zoom we're good.
Yeah, the one from YouTube have already been answered. The last one was made by Arnell in the limitations that encountered in
Yeah,
Go.
there is. I think there are a few more questions after that. So Karen
And
asked in Carmoody they had projects with Golang as well as they used Hugo. And oh, it's not a question. Okay,
no, it's not
that's
a
a mistake.
question.
Mistake.
No, that's not a
All right,
question.
my bad.
Karen was mentioning that I I think
Yeah.
Karen Matala was one of your team members back in Carmudi.
Yes.
Yeah, so
Hi,
she's
Karen.
online as
Yeah.
well. Yeah. So I guess last call, no questions, no other questions. I guess that's it. Marco, I'll let you take the floor.
Okay.
Thank you, guys.
Right. Thanks, everyone. Thank you, Ben. Before we go, I'd like to again say thank you to Freelancer and also obviously to the company where I belong, who's also sponsoring our Zoom Zoom call right now. So Brancas. So I guess if the lower thirds did not sort of like make it clear, I'm Marco Palinar. I am a product manager for Brancas, and yeah. So Golang is actually one of the is our main kind of like tech stack that we use. And we are hiring. So Brancas, we basically build the back end for open banking here in Southeast Asia. So building API services so that companies can have direct and more basically better access to banking services. Um, so we have three products basically. We have direct, disperse, and statement. So direct basically, yeah, it empowers your users to transfer funds via direct debit. Disperse allows you to disperse funds easier. So for companies that need to make multiple transfers per month to different accounts, so this is the product that we offer. And statement is basically it allows apps or companies to basically access verified transaction data from any bank. That's integrated with the Brancos platform. So these are basically all API products that we build, and Go is a big part of how we do this. So we are, like I said, we are hiring. You can go to Brancas/careers and check it out. So we're hiring both on the tech side and on our business side. So I especially want to highlight that we are also hiring senior and junior systems developers. So people that want to that have want to basically develop APIs, develop systems that connect to that connect services basically. And also we're also on the hunt for a UX UI designer. So if you don't know anyone, I know this is a developer meetup, but if you have friends who are UI UX designers looking for a job, we are also hiring, as well as junior and senior QA engineers, testers and engineers, right? Yeah, so that's it from my end. Thank you very much. We will host another virtual meet hopefully by next month. Is that right, Cheryl? Next
Yeah,
month we'll
hopefully
try.
by next month. If any of you who are listening in, if any of you would like to present something with regards to Go, like how, like what Ben just did, and how they use Go to solve certain problems, or how they use it in their own company. If you'd like to uh, show if you would like to show, or if you'd like to let us know how you have used Go to solve certain projects or certain problems that happen in your company, or maybe even present something like something you've learned uh, that you're using with some other technology that uses Go as well. Please feel free to reach out to us. You can uh, catch us online, like on Twitter. So on Twitter, we are. Oh my God, I have forgotten what our Twitter link is. I'm
They can
sorry.
probably search Go Manila on
Yeah.
Twitter.
So we have. You can go to the Go Manila PH. Go Manila PH on Facebook. All
Mm.
right. Go Manila PH, not Go Manila itself. That's a different story. Okay. And then on Twitter, we are Go Manila org. So you can reach us either through Twitter or through Facebook if you're interested in uh, giving a talk as well. So hopefully, maybe one of you will be one of our future speakers in our online meetups.
Sorry.
Marco?
Can I also mention?
Sure.
Sure, go
Um,
ahead. Go ahead. Please.
yeah, just want to say that we are also hiring in FoodPanda. I mean, in Singapore, our tech hub is. But we are closed right now to foreigners, to only Singaporeans. But once I guess the airports are back to open, we do visa sponsorship as well. So people in the Philippines, if you're interested in working with FoodPanda, yeah.
What current
Awesome.
openings are on FoodPanda right now?
Mm, uh, I think both front end and back end are open. Even engineering manager positions.
All right. Cool.
Awesome.
Yeah.
Yeah, thank you.
Oh, I'd like to point out also, Brackets, we're a remote first team. So even before the COVID thing, where we've been working remote. Essentially, that's how we're able to sort of like build our team, regardless of where you are. Yeah, that's fine. Sorry. Johnny, do you wanna plug anything on your side as well before we wrap up? All right. So everyone, I guess, is hiring. Thank you. Thank you for your time. Thanks, Ben.
Thank you
Thank you so
so
much for
much,
listening.
Ben.
Yeah, thank you for that. Was really, really
Welcome,
insightful
guys.
on how you guys use Go in serving out geo-aware marketing campaigns. And that's it, guys. If you have any questions, comments, you can direct it to join our group, or on Twitter. Just message us there, or find the Facebook page. We'll try to send it to Ben if you guys have thought of any questions after this. This live meet, or this virtual meet will be is recorded on on YouTube, so you guys can go back and watch this again. Thanks and good night, everyone. Thank you, Johnny. Thank you, Charo. Thank you, Ben.
Thank you.
Have a good night, everyone.